we consume milk from our very birth, and sometimes long after that. It is so normal that I never really questioned how mammals evolved to produce it. That was until I heard about pigeon milk. Then, I had many questions. In this episode, we will explore 5 preconceived ideas that I had about milk and lactation. 1. Only mammals produce milk. I already mentioned bird milk, also called crop milk, because it comes from the crop of pigeons, doves, flamingos, and also from the male emperor penguin. Some species of fish, like the discus fish, also secrete a mucus that their babies feed on. Just like in mammals and birds, discus milk is rich in proteins and antibodies, and it's controlled by the same hormone, prolactin. Some insects and arthropods produce milk-like secretions too. Tsetse flies don't lay eggs, but give birth to larvae directly. They produce a milky secretion in specialized glands to feed them in the uterus. The larvae never eats anything else. As soon as it exits the mother's uterus, it crawls into the ground and transforms into a pupae from which the adult fly will emerge. The Pacific beetle cockroach is also viviparous and produces a crystalline substance that is rich in fats, proteins, and sugars. This cockroach milk is believed to be one of the most nutritious and highly caloric substances on the planet, containing 3 times more energy than buffalo milk. Spiders can be maternal too. Scientists observed that the young of Toxeus magnus, a small jumping spider that resembles an ant, took a long time to leave their nest. They discovered that the mother secretes a milk-like substance that nourishes her young for up to 40 days. 2. Lactation evolved only once and relatively recently. Milk production can be a significant selective advantage for a species. It allows storing energy as fat when and where it's available, and releasing it at another time and place. That way, feeding the young becomes partly independent from the season and the direct environment. It also reduced the need for the mother to make multiple trips to gather food, like most birds do. This is probably why lactation and analogous mechanisms have evolved multiple times separately in different species. In birds, for example, pigeons, flamingos, and penguins are not closely related, and each one had to evolve its own crop milk independently of the others. 3. Mammary glands evolved after viviparity. The current consensus is that milk-producing glands evolved to protect eggs, and viviparity happened later. Prolactin, the hormone that controls milk production in humans, birds, and in some species of fish, dates from the earliest vertebrates, some 500 million years ago. It is actually a very versatile hormone that is involved in hundreds of different processes, and not just lactation. In fish, prolactin is crucial for maintaining salt and water balance, and that sometimes involves producing mucus. Over 300 million years ago, the amniotes, who are common ancestors from mammals, dinosaurs, and birds, had a glandular skin. They also already evolved to produce casein and alpha-lactalbumin, which would later become an important part of milk. The synapsids developed skin glands for moisture regulation and immune defense. As they evolved into therapsids about 250 million years ago, these glands could have secreted a fluid to protect and moisten the skin and coat their parchment-shelled eggs to prevent desiccation. In some therapsids, these secretions could have evolved to provide antimicrobial properties and might have transferred some nutrients through the eggshell. It would then have made sense for the hatchling to consume the remaining mucus. During the Triassic, 200 million years ago, the mammalia forms were very small in size, making large eggs impossible. They also had rapid growth and limited tooth replacement, which indicates that milk had already supplanted egg yolk as the primary nutrient source. By the Jurassic period, 170 million years ago, the genes coding for egg yolk production disappeared from mammals. That is when monotremes, egg-laying mammals like the platypus, Antheria, marsupials and eutherians, separated. 4. Platypus don't produce milk. I thought that since they lay eggs, platypus would not have mammary glands. They actually don't have nipples. But they do have mammary glands and produce milk to nourish their hatchlings, who lick the milk directly on the fur of their mother. This is probably what the early stage of milk production looked like. The Theria branch evolved to have nipples, and between 125 and 160 million years ago, marsupials separated from eutherians. The marsupials evolved to keep their babies in pouches and rely more on lactation, while the eutherians give birth to more developed youngs after a longer gestation period. Milk composition has evolved to match the needs of each species. In humans, the ability to produce milk that supports prolonged brain development has been a crucial evolutionary advantage, with the composition of human milk reflecting the needs of slow-developing, highly dependent infants. 5. Only females produce milk. In pigeons and flamingos, males produce crop milk too, and both parents feed it to the young. The female penguin doesn't produce milk, it's only the male, who is also responsible of keeping the egg warm for months, while the female feeds herself at sea. In some species of bats, such as the Dyak fruit bat, the male plays an active role in lactation and feeding the young. In most mammals, including humans, male lactation can also happen as a result of hormonal imbalance. This shows that males could easily evolve to produce milk. Since they haven't done that in the majority of mammalian species, there must be very little selective advantage to do so. I hope that you enjoyed this episode about the evolution of lactation. Please consider hitting the like button and subscribing to the Invisible Zebra channel.